Good morning everyone. I am Tirthashri and I am here to present assignment 1 on MiniATC Lexical Analyzer and Parser, which belongs to the subject Automata Theory of Computations. Our major aim is to design and implement a lexical analyzer and parser for the MiniATC language and verify whether the given program follows the correct grammar rules using the context-free grammar. So coming to the introduction part, automata theory is widely used in compiler design and programming language processing. In this project, a simple language called MiniATC is used to perform lexical analysis and syntax analysis. The system generates token and checks whether the program is grammatically correct using CFG rules. So the first analysis is lexical analysis. Lexical analysis is the first phase of the compiler. It reads the input program and converts it into the tokens such as keywords, identifiers, numbers, operators and delimiters. So then the second phase is the syntax analysis of a compiler. It checks whether generated token follows the grammar rules of a language using context-free grammar. It identifies whether program is valid or else invalid. So it will be the token types of keyword, identifier, numbers, operators and the delimiters. So the program structure will be look like this: begin and the list of statements we can put in this, later the end of the program. Then coming to the context-free grammar. Context-free grammar is a set of rules used to define the structure of programming language. It helps the parser check whether the given program follows the correct syntax and grammatical rules. So this is the basic form of the context-free grammar, where program will be begins and list of statements we will put here, and end of that later here int id, where id is equal to number. Then if we put the print command, it will print the program. Identifier recognition using finite automaton. Finite automata is used to check whether an identifier is valid or not. An identifier must start with a letter, which is a rules. Identifier rules is as follows: an identifier must start with a letter and can contain the letters or digits. If the input follows these rules, it is accepted as a valid identifier. So finite automaton design will be look like this. Q0, consider it as a start state. Q1, consider it as a final accepting state. Transitions are from Q0 to Q1, that is on letter. From Q1 to Q1 on letter or a digit. It may be the strings may be the combination of letter and string, and transitions from the start state to final state will be as the transition from Q0 to Q1 in the form of letters, and Q1 to Q1, that is self loop, that is on both letter or a digit. So for that, DFA is like this. The finite automaton for the identifiers will be start state Q0, Q1 final state, which is accepting state. So from the start state we are pushing the letter. The transition is of letter, and in the final state the transition of both letter, combination of letter and digits. It can accept both the letter and digit. The DFA is a finite state machine used to recognize the patterns and validate strings. In a DFA, for every input symbol there is only one possible transition from a state. It consists of states, transitions, a state, start state and accepting states. So in this project, DFA is used to recognize valid identifiers in the MiniATC language. So this is the flow of our working process of MiniATC. That is, flow diagram represents the working process of MiniATC system. First, the input program is read. Read the input of the program. Then a lexical analysis is performed to generate the tokens. After the syntax analysis, checks the grammar rules using the context-free grammar. Finally, the program is identified whether as a valid program or else invalid program. So let me show you the main code and the output in the Visual Studio. This is the test cases. Test case 1 valid case and test case 2 is invalid case. Later conclusion, the MiniATC lexical analyzer and parser were successfully designed and implemented. The lexical analyzer effectively converts the input program into tokens such as keywords, identifiers, numbers, operators and delimiters. The parser then verifies using the context-free grammar the system is capable of identifying both valid and invalid program based on their structure. The assignment clearly demonstrates how the concept of automata theory and formal languages are applied in the real-world compiler design, particularly in program analysis and validation. Thank you. So the program is implemented using Python. It contains two main parts, lexical analyzer and parser. The lexical analyzer converts the input MiniATC program into tokens, while parser checks whether token follows the given context-free grammar rules. This is the main code.